So in part D, we have 2b times the cubed root of 16b squared plus 4 times the cubed root of 128b to the fifth. Remember, the directions are to simplify any radical you can. Simplify that first. So let's think about the cubed root of 16b squared. We have a 2 times b on the outside. It's cubed root, so what kind of powers are we looking for? In the factors of 16b squared, what kind of powers are we looking for? Perfect cubes. 16 is actually 2 to the fourth. So how would you break up 2 to the fourth? 2 to the third times 2 is 16. I didn't do a factor tree on that, but we've done it more than once already. Does that make sense? Or that sort of problem more than once? And I'll do the other radical in a second. What does that mean I can pull out of that first radical? The cubed root of 2 cubed is 2, so just do it this way. Pull it out and write down the operation. It's multiplication, so write down dot for multiplication. Does everybody see how I did that? That's the first radical simplified. Well, I still have to do the 2 times 2 make 4, but basically that's it. Let's simplify the other radical. Don't forget the operation is plus here, so bring down the plus. And then, 128, I might have to do a little factor tree on 128. What numbers do you think of multiplying together to make 128? 2 and 64 would work, right? And then 64, 8 and 8, and then we know that 8, if you multiply 3 2's together, you get 8. Oh, how many 2's is that altogether? Count that one. 2 to the 7th. So 128, it looks like it's 2 to the 7th. Would you buy that? How do you want to split that up into a perfect cube factor and a non-perfect cube factor? 2 to the 6th, because 3 divides into 6, right? Times what's left over? 2. So that would equal 2 to the 7th. Now what about, how are you going to break up b to the 5th? We're looking for perfect cubes, so b to the 3rd times what's left over is b squared. So does everybody understand what I did right there? You factor out basically the largest perfect cube factors you can, because you're looking for perfect cubes and you can take their cube roots. That's if the index is 3. Okay, so let's do that. I should have left some room here to begin with. So let me circle my perfect cube factors. 2 to the 6th, b cubed. So what can I pull out? What's the cubed root of 2 to the 6th? Now it makes sense. The shortcut should make sense to you. It's the cubed root of 2. It breaks up, so you can think of it, the root breaks up. You can think of it as the cubed root of 2 to the 6th. That's 2 to the 6th power over 3, isn't it? So you're going to pull out, divide 6 by 3, keep the base. You're going to pull out a 2 squared, aren't you? So pull out a 2 squared as a factor on the outside, and then cross this guy out. Does everybody see that? How I got that? Okay, what else can you pull out? Ask yourself, what is the cubed root of b cubed? It's b, and again, we're assuming b is positive, but it doesn't even matter because it's an odd indexed root here. So you're going to pull out a factor of b, cross that one out, pull out a factor of b. Cubed root of b cubed is b, okay? Does everybody understand what I did? So we're getting a little review of simplifying radicals within this problem, and I want to make sure you guys understand it, okay? All right, let's clean this up. In the first radical, what do we have out front of the radical? Just 2 times 2, so 4b times the cubed root of what? What's left inside? Is that okay? What's left inside? 2b squared. Right? That radical simplified all the way because in that radicand you don't have any factors that are perfect third powers or above. So you know that's simplified. Plus, what do we end up with for this outside of this second radical? 4, 2 squared is 4 times 4 is 16b. And then what's left? Cubed root of 2b squared. Could you look at these guys as like terms? Yep. So when the radical parts are exactly the same, you can, as long as they're like terms, you can add the parts outside the radical, keep the radical part. So it's like taking a 4b times x plus a 16b times x. You could combine the like terms, 4b, 16b, and then whatever the other part is as a factor after that. In this case, the radical. So what would the answer be? 20b, is it b squared? No, on the outside, it's just b, isn't it? Yeah. Because we started out with 2b here. That was the given. So 20b, and then what's the radical part? Cubed root of, there's your b squared, 2b squared. So that's what you were thinking of. Again, this is a cubed root. Don't think of it as b cubed out there. It's just a factor of b out there. 20b times a cubed root of 2b squared. Any questions on that? That is the answer. Let's do one more of these. Part E, we have the square root of 9x minus 9 minus the square root of x cubed minus x squared. Okay, what can we do underneath the radical? The first radical, let's say. Yeah, well, we can, but there's a step you should probably show first. Oh, I think you actually meant the right thing. I thought you said take the 9 out of the radical. But no, you meant factor out the 9, didn't you? Okay, so what do you get when you do that? 9 times x minus 1 underneath the radical, right? And then in the other one, what could we do? Factor out an x squared underneath the radical, and then what's left? So x minus 1. So what can we pull out of the first radical? Remember, the radical really does split up. So it's really, that first radical really is the square root of 9 times the square root of x minus 1. Oh, it splits up over multiplication, not over the minus. So it splits up over this operation of multiplication between the 9 and the x minus 1. It's not going to split up over the x minus 1 ever. So you could think of this as, normally I wouldn't write this step down, but it's crucial that you don't misinterpret it. You can think of this as the square root of 9 times the square root of x minus 1. You cannot break up this square root because the operation is a minus between the x and the 1. So you got to leave it as is. Oh, and then what's the square root of 9? So you get, for the first radical, you get 3 times square root of x minus 1. That's how it simplifies. Now, what about the second radical? It's going to stay minus. What can you pull out? Assuming that the variables are non-negative, what can you pull out? An x, right? Square root of x squared. If you wanted to rewrite it, though, so the step you're not going to show necessarily is this one. But since I showed it for the first radical, I'll show it for the second one. Square root of x squared, I don't know why I did it in red, times the square root of x minus 1. We're splitting up over this operation of multiplication, right? And then likewise, you can't split up the square root of x minus 1. Then what's the square root of x squared? As long as x is non-negative, x times the square root of x minus 1. So are the radical parts exactly the same? Yeah, but what's the problem with combining them? If you try to take 3 minus x, you're out of luck, right? Because those guys aren't like terms. The best you could do is factor out the radical. So if you undistributed the radical, brought the square root of x minus 1 to the outside, what would be left on the inside? In parentheses, the 3 minus the x. And you could, yep, it's this operation's multiplication. Whoops, that's supposed to be an x right there. Hold on, let me fix that. So hold on just a second, then I'll answer your question, Ryan. Does everybody see what I did there? Factored out the radical on the right, didn't I? And then Ryan's question is, can you put the radical on the left? Yes, absolutely, because multiplication commutes. 3 times 5 equals 5 times 3. So 3 minus x times the radical is equal to the radical times 3 minus x. Yep.
X minus 3 is the same thing, right?
X minus 3 is not the same thing. Big old not equal to is 3 minus x. They are opposites of each other, right? So that's how you add and subtract radical expressions.